Hello everyone, I'm Jay Navadia from the batch of 2020, currently pursuing ICT with CS here at DICT. So this video is about the project submission of our project video streaming with RTSP and RTP, and I'll be guiding you through this video. So RTSP is real-time streaming protocol and RTP is real-time transfer protocol. Our team ID is TF3 and the members are Devansh, Dhruv, Achyut and me. Of course, this is a part of our project submission of IT304 Computer Networks course, and we are very thankful for the guidance of Professor Sasidhar and teaching assistant Dhara ma'am. Moving forward, we are going to cover these five topics in this presentation: introduction and requirement analysis, function description, block diagram, bonus exercises, and the results that we got. In the introduction part, we'll understand what RTSP and RTP is and the requirements on client and server side. In function description, we'll talk how we made the functions that were incomplete in all of the files, that is the client.py file, server.py file, and RTPpacket.py file. And then we'll have a quick look at our block diagram, that is the block diagram of the whole system, that will help you understand what the system is actually doing. Then we'll look at the bonus exercises that we completed. The three bonus exercises were mentioned in the manual, and we completed all of the bonus exercises. First, we calculated the RTP packet loss and data rate. Then we made a three-button client, that is the play, pause, and stop buttons without requiring a setup button in the client. Then we made a describe button, and more on that later. Then finally, we will conclude with the results and the user manual. Moving ahead now, I'll brief you about our project and what all was required from our side to complete the project. So first up, let's understand what RTSP and RTP is. As it is a key part of the project because we are going to use both of these protocols later on. So RTP is real-time transfer protocol, meanwhile RTSP is real-time streaming protocol. RTP is used for data delivery, while the RTSP is just a control protocol and it is not used for data delivery. Now, by default, RTP uses its control protocol RTCP, but we are going to use the RTSP control protocol. Now, RTCP and RTP uses UDP for its data delivery. Meanwhile, the RTSP uses RTP for its streaming part and TCP for its controlling part. So we'll have a look at the code and I'll tell you where we are going to set this RTP and TCP part. Now, the port of the RTP is in unprivileged range. It is after 1025. Meanwhile, the RTSP has a default port number 554. So, as I said, the RTSP socket uses TCP. Meanwhile, the RTP socket uses UDP for its data delivery and controlling part. So, as you can see, the RTSP socket is opened in the server.py file and it uses socket.sockstream as one of its parameter in the socket function. So, the RTSP needs to have a TCP socket. Meanwhile, the as we can see in the server.py file that the RTP socket is opened here and it uses socket.sockdiagram for its parameter because it uses UDP for its controlling part. Moving forward, now we are going to talk about the requirements that we need to complete on this project. So first up, we will see what we need to complete on the client side. The RTSP protocol we need to complete on the client side. Also, the send RTSP request function, pass RTSP reply function, and open RTP port function we need to implement. And we also need to implement the setup, play, pause, and tear down actions. So the buttons are already implemented, but the actions we have to implement and the request that we are going to send when each of these buttons are pressed, we'll need to implement that part. And on the server side, we'll need to implement encode function in RTPpacket.py. That is for the packetizing the RTP packet, and we need to manipulate bits for doing so. In this section, I will explain in detail all the functions in the client.py, server.worker.py, and RTPpacket.py files. Now, other files are just simple helper or wrapper classes to take in the arguments and initialize the before mentioned classes. First up, we have client.py file and the constructor in it. Now, the client.py file implements the client class. The constructor initializes the following properties of the class. The master, it contains the ticket root widget and it's also set to call the handler method when the close button is clicked. Then we have server address and server port that contains RTSP server port. Then RTP port that contains the RTP port. Then file name that contains the desired file that we need to stream. In our case, that is movie.Mjpeg. Then we have the RTSP sequence number that contains the sequence number of the RTSP packets, then session ID that contains the RTSP session ID, then request sent that contains the information about last request sent, and the purpose of this property will be made clear when I explain later methods. And there is tear down acknowledge. This value will be set to 1 when an acknowledge for tear down request is received from the server. Then we have frame number that contains the current frame number of the streaming video. Now, also, the constructor contains a create widgets call and connect to server call. Now that is for creating GUI and connecting to the RTSP socket. You can look at the code in our GitHub repository so that it will be more clear. Next up, let's talk about these functions. First, we have connect to server function. Now, connect to server function is a short method to open a TCP socket on the client and connect to the TCP socket opened at the server. The reason this socket is a TCP socket because RTSP uses TCP to maintain connection. Also, if the connection fails, it will throw a take enter error box. Then we have the create widgets function. This is also a GUI function. Now, this method creates a GUI with 4 buttons in a label. The 4 buttons are organized on the same row with the text setup, play, pause, and tear down inside. Now, the label is placed above the buttons and is where the video will be shown. We customize this GUI for more user-friendly interface. Now, next we have the handler function. What it does is that this is a small handler method that gets invoked when we click the close button. What it does it will send a pause request to the server that opens up a message box to ask if the user really wants to keep. If that is the case, it will send a tear down request to the server. Otherwise, a play request will be sent. Now we'll check this part of the code. Now set it up. Now let's play it. Now while playing, let us try to close the RTP client. Now it asks us if you really want to quit. If you cancel it, then the play request will again be sent and it will play. And if you press OK, the tear down request will go. That is all the handler does. Now let's get back to the presentation part. Now, next up, we have the open RTP port function. Now, this is a method that we need to complete. It is quite simple though. All it does is open a UDP port, set a timeout for it, and bind it with the RTP port on the server. The reason it is a UDP port is because RTP is a streaming protocol built on top of UDP. It will also throw an error box if the binding process is unsuccessful. Next up, we have the 4 functions that are setup movie, play movie, pause movie, and exit client. Now, these 4 methods correspond to 4 actions when the user presses the button. All of them will send a corresponding RTSP request to the server. Furthermore, play movie will create a thread to listen to incoming RTP, and exit client will destroy the widgets and clean up the cache files. Next, we have the listen RTP function. Now, this method is run on separate thread created when the user clicks the play button. It continuously listens to incoming RTP packets, decode them, and then display its payload as a frame on the video label through the update movie method. It also takes the sequence number of the RTP packet and compares it to the current video frame number. If the RTP sequence number is equal or less than the current frame, the packet will be treated as a LAT packet and will be discarded. Also, if there is a pause or tear down RTSP packet received, there will be no more RTP packets to receive. When that happens, it will handle the exception by stop listening and close the RTP port on tear down. We have 4 more functions to link in the client.py file, that is the update movie and write frame. These are 2 small helper methods to show the payload of an RTP packet as an image on the video label. What they do is to save the payload to a cache file, then display the content of that file on the GUI. We have a send RTSP request function. That is a very important function that we implemented. So in this part, what we did is that we need to first check if the request can be sent or not. So some requests can only be sent in some states. So for example, setup request can only be sent in the init state, play request can only be sent in the ready state, pause request can only be sent in playing state, and the tear down request can only be sent in both the ready and playing states. So in case of setup request, the client will start a thread to listen to incoming RTSP replies. The setup indicates the start of an RTSP session. So the RTSP sequence number is set to 1. RTSP request packet for the setup request, we'll see that later on. Same for the play request. Now for the other types of request other than the setup, the sequence number is incremented by 1. Meanwhile, in the setup request, the RTSP sequence number is set to 1. So also, the contents of the packets are identical except for the request part of the code. We'll look at that later on. Now, also, the program that we have completed is in Python 3. So the data to be sent and received over a socket must be of type bytes and not strings. Therefore, the request must be encoded before sending, and we do that by using the method encode. We'll see the encode method later on this presentation. Now let's have a look at the code that I was talking about. So we are in the client.py file and have a look at the send RTSP request function. It takes in as parameter self and the request code. Our request code are also set up very before. The setup for 0, play is 1, pause is 2, tear down is 3, and describe is 4. Describe is a additional function that we'll talk later on. Now let us see the function send RTSP request. Now first up, if the request code is self.setup, then the and also the state is init state. So what we'll do is the initialize the RTSP sequence number to 1. We'll start a thread for receiving the RTSP reply, and then we write the request to be sent. Now this is the request is going to be in string format. So at the end, what we are going to do is we are going to encode this request, and here is the code for that. Why we need to encode this is because the data to be sent or received must be the type of bytes and not strings. So the encode function will help in that. The encode function is a part of RTPpacket.py file, and we'll talk more on that later on. Now, let us see what are the functions that we need to implement in the Server.worker.py file. So there are 5 functions that are in the Server.worker.py file. We'll have a look at them. So first up, we have the constructor init. So in the server worker class, the properties are not stored separately like in client, but instead they are stored in a one single directory called client info, which gets initialized in the constructor. I'll show you the code later on. Then we have the receive RTSP request function. Now this is the same as receive RTSP reply in the client. It is running another thread to listen to incoming RTSP request packets. When there is a packet, it will proceed to decode it in UTF-8 encoding and pass it to the process RTSP request function. The process RTSP request is a very important function that we implemented. So what it does is that we need to process the RTSP request and have a reply ready. So what do we do is that first off, it is almost identical to the past RTSP reply function. Now it will pass the RTSP request packet by split function, then process it and update its state differently based on the request type, and finally send a RTSP reply using reply RTSP. If the request is set up, the state will be ready, a random session ID will be generated. Now, if the request is play, the state will be set to playing, and UDP port will be open for streaming the RTP packet, and thread will be open just to do that. And if the request is pause, then the state is going to be set to ready, and the streaming thread will be stopped. If the case is tear down, then the streaming thread will be stopped, and the RTP packet will also be closed. Now the reply RTSP function, what it does is that this method is just used to inform the reply packet and send it to the client. Now there are 3 RTSP status codes implemented in this system. That is 200 for OK, 404 for file is not found, and 500 for there is an error connection. Now also there is a last function named send RTP. Now this method runs in another thread to continuously stream video frames as RTP packets to client every 0.05 second, that is 50 milliseconds. It first gets the next video frame using the helper methods in the video stream class, then puts it in a valid RTP packet and finally sends it to the client. There is also a function that is make RTP. Now what it does is this is where an RTP is encoded. This method passes several hard-coded header fields into the encode method of the RTP packet class. Now we are going to build the encode function, and I'll show the make RTPs used in that part now. Now let us have a look at the code part of the Server.py and the RTPClient.py file. Now first up we have the Server.py file here. So the these all files are imported in here. So first up we have the initializer, the client info is there. The As I talked before, that we are not making separate fields. We are just going to make a client info directory, and we are going to store things in that only. Now there is the run that makes a thread and starts the function. There is the receive RTSP request that opens up a function, and it also decodes any receiving RTSP requests in UTF-8 format. Then there is the process RTSP request. This is the most important part of the code. Now in this one, we are going to see what happens if the requests are. So first up, we have the split function. We are using it for splitting the data, and then we are going to use the if else and try except for manipulating what we need to do. The first up, if the request type is set up and the self state is init, then we are going to just print it out, and uh, this is we are going to change the state of the client. That is, the client is now ready to receive the data. And moving forward, the reply RTSP is OK 200 if no problems arises, and if any problem arises, the except function will send the reply of 404, the file not found, if the try fails. The same thing goes for the play part. We are going to change the state to playing if the play is indicated and the the state was ready. Now what we are going to do, if the pause is there and the state is playing, so we can use the pause, and we'll change the state to ready. We'll move on with the reply OK 200, and in case of a tear down, we'll just uh, close all the GUI and clean up the cache. In case of describe, we send a OK 200 file, and make a describe file that we'll talk on later on. Then there is the send RTP file. What it does is that it sends the packets every 0.05 second, and that's all that it does. And make RTP is also there. What it does is that the RTP packet will be have to be encoded, so it sends it into the encode function. So we'll have a look at encode function later on. The encode function is in the RTP client RTP packet.py file, and that is imported as we can see here. Now let's go to the RTP packet.py file to see how the encode function works. Now let us have a look at the RTP packet.py file. So as I said, we moved on to the RTP packet file as the make RTP calls the RTP packets encode file, encode function. So first up, the encode function will do what? It will encode the header. So we are going to manipulate bits and bytes to the values that are going to be stored in the 12 bytes of this one. What do we need to implement is that first of all, the 4 bytes, as we talked, will be stored in the first byte of the header. We need to do it manually because it's a byte array, and it can only be done in the byte array because we are using Python 3. So first byte is set with version, padding, extension, and CC. And as we can see, we can use the syntax given in the manual itself to set the bits. Then the second bit is set with the 7 bits of marker and 1 bit of PT. Then, as we can see, the second bit, the third bit is now set with the sequence number, and third also. because we need 2 bytes of a sequence number. So we can do it by you following this syntax. Now, if we need 4 bytes, then we can also use that syntax, and the timestamp is stored in the fifth, sixth, seventh, and eighth number of bytes in the header. Then also the SSRC's 4 bytes are stored like that, and then we set the payload, and the header is done. The encode does its the header and payload is now separated. That is all the decode function does. Going forward, we have the RTPClient.py file. In this one, we have to implement the encode part. Now this is where the all the fun lies. So this is the most important method in the class, and we are required to complete it. Basically, all this does is to put the bits and bytes of the values in the header fields and puts them in their correct place. As shown in the diagram, that is just a header diagram of the RTP. So what we are going to do is that the first byte is for the version padding bit, extension bit, and in that 4 bits are for contribution source bit. The second byte of the header contains one marker and 7 bits for payload type. The next 2 bytes are for sequence number, that is in big endian, and then the next 4 bytes are for timestamp, that is also in big endian format, and the next 4 bytes are for SSRC, the synchronization source identifier, that we also need to implement it in the big endian. And the next 4 bytes are not going to be assigned as it is suggested in the manual. And finally, the payload is added to the packet in this function. So we'll see the code later on. And there is the decode method. Now this method contains only 2 lines to separate the header and the payload from a whole RTP packet. Also, there are other methods, but they are just helper methods to get the value of a specific field or the header, or to get the payload. So we do not need to worry about this, as that all are already implemented. Now, let us have a quick look at the block diagram of the system. So, we have RTP packet server, server worker, client, and video stream. You can have a look at it and later on, or you can pause the video and have a look at it. It will basically explain you the whole system and how the flow goes. Now, let us have a look at the bonus exercises that we completed. We completed all of the bonus exercises. First up, we have the performance evaluation bonus exercise. In that part, we calculated the RTP packet loss rate and data rate. So, let us talk about how we implemented the RTP packet loss rate. So, we need to calculate how many packets were lost and how many packets were sent for finding packet loss rate. That is pretty simple. Now for finding the packets that were lost, we need to compare the sequence number of the received RTP packet to the frame number that it should be, which is the current frame number plus 1. If it is not equal, we have a packet loss. Now for finding the total number of packets sent, it is the current frame number at the time the packet losses rate is calculated. And we are going to calculate the packet loss rate at the time when the tear down action is triggered. So now let us have a look at the code of it. Now we are going to insert the code that detect the packet loss in the listen RTP method if the frame number plus 1 is not RTP packet sequence number. Now that is the packet loss, and we are going to increment the loss counter by 1. We can find a number of packets lost from there, and then at the time of exiting, when that's when the tear down request is triggered, what we'll do is we'll just divide the loss counter divided by the frame number. Now that is the number of packets lost divided by the total number. Now that gives us the loss rate. Moving ahead, let's talk about the RTP packet data rate and how we'll implement it. So for calculating the data rate, we'll first start the timer when the play button is pressed and end it when the pause button is pressed, so that streaming can be evaluated. Now we'll show the data rate once the pause button is pressed. Now, the number of video data received is total length of all RTP packets payload. So we can implement that by using this line of codes, the self.bytes received plus equal to length of RTP packets payload. So now what it will do is the bytes received will now contain the total length. So now we'll need to divide it by the time. So that is how we can get the data rate. We'll get the data rate in bytes per second. Moving ahead, the 3 button client. Now, a client with three buttons, that is play, pause, and stop. It is very easy to implement it because we just need to get rid of the setup button. For doing that, all we need to do is when the first time the play button is pressed, we'll send a setup request. And when the stop button is pressed, it is equivalent to the tear down RTSP request. So we'll just need to send a RTSP tear down request. So let us see how we implemented that part. So the what we'll do is in the play movie function, if the state is init and it is the first time we are playing it, so first time the play button is going to be played. So what it does is it sends a setup request. As you can see, the self dot send RTSP request self dot setup, and the first play is now false. The first play is just a boolean or any integer variable, and just by manipulating that first play button, we have implemented the three button client. And when the state is ready or playing, we can just send a tear down request for the stop button. It's very easy. We just need to change that part. Uh, Now going forward, now the describe part of this one. Now the describe button is added to the client, as you can as you have seen in the previous slides. If the photo is added, now the client send a RTSP describe request and server replies with us storing a current information, the statistics in a file named session.txt. Now the implementation, how we'll do it. We'll add one button in the GUI, the describe button in the first row, and move all the other buttons to the second row. Then we'll create one send RTSP request case, then create a pass RTSP request case and modify the server worker accordingly for the describe request. Now it stores some data like the session ID and the video file name and its type into a session.txt file, and it's just another button to get this info. I'll show you the describe working in the demo that I'll give you at the end of the recording. Now, streaming time, how I calculated the streaming time. So now let's talk about the streaming time calculation. So, for live streaming time calculation, we use the multiply the frame number of the current frame by 0.05 and take its integer part, and then we just modulate with 60 to show the seconds and divide it by 60 to show the minute part. Now I'll demo you this in the demo part. I'll show you the streaming time working in the demo part. So hang on. Now let us have a look at the results and testing of the application. So first up, we tested it on one local machine, that is the MacBook Air M2 that I'm currently recording this video on, and then we tested it on the two machines that we connected them remotely by making the MacBook Air M2 a server and the MacBook Pro a client, and it works seamlessly. And the interaction with the client, that was also good. The buttons were responsive, and we also implemented the disabling the buttons feature that are not required. That is when if the client is not setted, then we cannot press play or pause button because that is not required. So we use the disabled method that the GUI in the PIL library provides. Then going ahead, the string and termination part. The stream was around 25 seconds, and after that, and it was terminated successfully after the stream was completed. And there was a bit of a delay sometimes, but it was not significant. Now, now this is the loss rate and data rate calculation. Now the first experiment that was done on the local machine, the data rate was 1,34,112 bytes per second, and the loss rate was zero. As you can see, the loss rate is calculated when paused or when ended. And you can see the second experiment was also done on the same machine, and the data rate was 1,19,595 and then 91 bytes per second, and the loss rate was zero. And in the third experiment, we connected two machines, and you can see the data rate is 1,19,000, 2,000, and 224 bytes per second, and the loss rate is zero. And now let's have a look at the user manual. So first up, you'll need to have a Python 3 installed in your computer if you are using Mac operating system. Then you have to install the PIL library by running pip3 install pilo. Then you are good to use the project that we have. Now go to the project folder by using the cd command and then run the server in one terminal and client in another terminal. You can run it with the commands that I've written here. And note that the RTP port must be between 1000 to 25 and 65 536 because it is in the unprivileged range. And the server port number can be anything after 1024. And server IP you can get it by using ipconfig get if addr en0 if you are using it remotely. So you'll have to find out the server's IP address. So you can find out the server's IP address using this uh, command. Now, if you are stream from one terminal to another terminal in the same desktop, so what you'll need to do is you'll have the server IP as localhost. You can just type localhost and that will be your IP because you are not connecting the client to the server remotely. It is locally on the one machine. Now I'm going to give you a demo of how to run the project. First up, we open the terminal. You can open any terminal. I'm using the PyCharms terminal because it just opens the terminal in the directory that I am currently right now. Otherwise, you'll have to use the cd command and go to the project directory and then run these commands. So first up, we'll start the server by using Python 3 Server.py and let's give the port number 1025. It's the first available port number to us that we can use for the purpose. Because we cannot use 1024 or lesser number than that because that are privileged port numbers. We need to use 1025 for our project's purpose. Now the server has been started. As you can see, the RTSP is listening for incoming requests. Now let us start the client. So we'll just open another terminal and that will be like another machine but locally. So we'll start the client on this terminal. So what we'll do is we'll launch the client by using client launcher.py. Then we'll give it the port number of the we'll give it the IP of the server, that is the local host. Right now we are local machine on local machine, so we do not need to worry about the port number, sorry, IP. The port number is 1025. Then we will have to give it the RTP port number. RTP port number I'm giving it as 5008. You can give it anything after 1024. And then the file to be transferred or streamed is movie.Jpeg, movie.Mjpeg, and that is all we need to do for launching the client. Now let's launch the client, and the client is now launched. As you can see, the client uh, our group ID is TF3 RTP client that I modified, and I also modified the GUI. Now, when we are not set it up for the streaming, there is no point of playing or pausing buttons or tear down. So what we do is we disable the buttons if the client is in initial state. Now, once we tap the setup, now the client is in ready state. So in ready state, what are available options? The play, tear down, and describe. So we cannot tap on pause or setup button now. So now we can play the stream right now because it is in the ready state. Now, as you can see, the stream is playing. We can pause, we can play, we can pause. So as you can see in the local terminal, local 2 terminal. Now local 2 terminal, the client is running. So the video data read is showing right now. So because we implemented the extended bonus features that we had to do. And then in here, we can see the requests. That is a pause request coming into the RTSP. C sequence number is 5. We have done 5 total actions, and the session ID is here, and processing pause. Now, if I click on describe, the describe request is gone. And what this will do is it will open up a session.txt file with some information. So I'll show you that right now. The computer networks, our project, and session.txt file. So as you can see, the session.txt has right now the protocol that it's using, the version that is using, the stream type, and the That is all that we have in the describe action. So that is all that the describe button does. Now let us play and pause and let us send the tear down request. Now it is tear down. The local machine has been closed. As you can see, the packet load state is 0, and the video data rate is 1,37,988, around 1,38,000. So that is good. Now let us have a look at how we can run the three button client. That is the play, pause, and stop buttons. So as I already talked that we do not need to have a setup button because we can just send a setup RTSP request when we press the play button for the first time, and that is what I implemented, and that is what I uh, talked earlier. So now let us start the server here. For starting the server, we'll write this code. Server is the same, it does not need to change. We are changing the buttons. Let us give the port number 1025. Again, the port number cannot be lesser than 1025. It is the first available port that we have that we can use. Now as we can see, the server is listening for RTSP incoming requests. Now let us start the three button client that we have to start. Python 3. We'll start the client launcher 3 button.py. Let us give the IP of the server, that is the local host, because we are experimenting this on one machine only with two terminals. So localhost is there, and now we need to give it the IP of our project, the port number of our project that we are going to use 1025, then the port number of RTP, that is 508 5008. That can be anything greater than 1024, and then the name of the file that we need to stream, that is movie.Mjpeg. And there we go. Okay, okay, so I mistakenly wrote a wrong name of the Python file. Let us change that. It's launcher, not launcher. Launcher, and it should be fine. Now, as you can see, it only has about three buttons and one describe button that we added for extended functionalities. Now let us send the play for the first time, and it should start playing. Now, yes, it started playing. What it does is it sent a setup request, and it then sent the play request on itself, and now it's in the ready state. It will not go to the initial state right now. Play and pause, and the stop is equivalent to the tear down, and the state will be then initialized after I press the stop button, and that is all. And as we can see the video data rate here, packet loss also here when we tear down the client, and the server is already looking for it and already finding a new clients to connect to after tearing it down. And the session ID, as you can see, remains the same. The C sequence changes, and the request we can see right now that we implemented uh, in the request part. So let me show you the requests. Client.py. The requests can be seen from here. As you can see, the setup request is like this. The play request is like this. The pause request is like this. It's almost similar for others than the setup, and that is all. Now, one more thing. Uh, Let us say if you want to connect one machine to another machine, so what you can do is you can find out the IP, that is by ipconfig getifaddr en0. As you can see, the IP is shown here. Now what you can do is you can turn this machine into a server and turn another machine that you have a client. In both of the machines you have to go to the directory of the project, and then When we were writing the local host, you just have to write this IP, and the one machine will be streaming. The client will be streaming the video in no time, and that is all. If you need to connect it to the another computer, we also tested it with another computer by using the same IP in place of local host, and that is all. Thank you. And the project source code is also available at GitHub. I'll give a link to the GitHub repository in the description below. And the presentation file is also there. And you can check out the full course and the explanation part over there. Now, if you have any doubts, please reach out to us and any of these mails, and we'll answer your questions. Thank you.